Hi, I'm here to explain how to use Artax to acquire and analyze a set of data. Our beginning assumptions are that you have Artax version 8.0.0.476 or later, and Bruker Toolbox version 1.6.0.110 or later installed on your PC. And you have Bruker S1 software version 2.4.54.297 or later installed on the instrument. Finally, we assume that your instrument is connected to the PC. We start Artax by clicking the appropriate icon, which brings us to a warning screen to which we click Yes. At this point, we'll input the password, which is TEST, and this opens the program. At this point, we can connect to the device by clicking Device Connect. This brings up the instrument in this box, and we click Connect. At this point, we get a series of colored bars up at the top of the screen, ending in a green bar for successful connection. Next, we want to establish a method. We can do this by either clicking on the Methods box or by going to Measurement Method. In this box, we want to create a new method, and we'll call it Art Test. And I click Add to add a new method. Now I want to set the current and the voltage, and I'll set the voltage at 40 kV, the current at 4.5 microamps. I want no filter, and I'm going to use 10-second acquisition time. Or I could simply select one of the pre-programmed illuminations which were loaded from the instrument when the connection occurred. In addition, I want to note the atmosphere that I'm using, the collimator that I'm using. In this case, I'm using an 8mm collimator, and the manual filter. In this case, it's blank. Finally, I want to select the directory where I'm going to save my data. In this case, I've got a directory I call temp, which I will select. And we have a root name for the data acquisition. At this time, I simply click Replace and OK. I now see that the method I'm using is called Art Test. Next, I want to start the remote program. Again, I do this by clicking the appropriate icon, and when the box comes up, I go to File, Connect. Again, the instrument number will show up, and I click OK. After a few seconds, the image of the instrument screen will appear on the remote control, and I'll move it over here. When you're ready to take data, we'll be using the camera. We are now ready to begin the actual acquisition of data. The first thing I do is click on the camera icon, which brings up the camera image on the remote control. In this case, I have a painting with large swatches of color, and I'm going to start with the tan image. To start the actual data acquisition, I go to the arrow icon and click it. This results in the beginning of acquisition, where I'll have the X-ray icon blinking in the Artax, I'll have the time elapsed in the remote, and the actual count rate on the remote. Once we've completed the acquisition, I can store this data with a file name by going to Save Spectrum As, and I will call this TAN. And save. All right. Now I'm ready to take my second set of data. I go back to the camera image, and in this case, I'm going to be shooting the green image. And again, I simply click the Start icon and repeat the process. At this point, I will collect several sets of data and will process when I've got them all collected. I have now acquired 6 different spectra that we'll need to process. The first thing I want to do here is create a project to contain these spectra. I do that by going to the Project tab, click Project, and click New Project. This creates a project column on the left side of the screen. The next thing I have to do is I have to add a node to this project. So I select Objects, go back to the project icon, and click Add Node. In this case, I want to call the node Points. And I click OK. So in the Objects, I now have a Points folder. What I want to do is I want to add all of the spectra to that Points folder, and I do that by going to Project, Add Spectra. At this point, my Points folder now contains all of the spectra I have accumulated. We are now ready to analyze the data. There are several controls that give you better viewing capability of the data. The first is this magnifying glass icon, which allows me to expand any part of the spectra. Once I've done that, I can zoom the intensity axis by clicking on the intensity axis and scrolling up and down. I can scroll in the energy axis by clicking on the energy axis and moving right and left. Now what I need to do is identify the elements in these spectra, which I do by clicking on this icon, which brings up the periodic table. By clicking on the various elements, I can see whether they exist or not. For example, if I click on the sulfur icon, that line lines up very well with peaks in the spectrum. I've got argon from the air. I've got potassium, calcium, titanium, iron, copper, zinc, and strontium. In addition, in this spectrum, I have the rhodium tube lines, and what I see right here are the rhodium backscatter, the rhodium Compton lines. The last thing I do before I save this is I can test whether that set of lines fits the data well by clicking this evaluate icon. If you notice, what happens is a blue line is added to the spectra, and what you want is you want that blue line to fit the data fairly well. If you look right here where the rhodium Compton is, we do not have any fit because that line was not identified. You can add and subtract lines from this by simply clicking on additional elements on the periodic table. Finally, what I want to do before I leave this is I want to save those lines, and the way I do that is I go back to the Method tab, I go to Identification, I click Preset Lines and Get Elements. This imports all of the lines that I've just chosen on the spectra. The last thing we want to do with this data set is output the data to an Excel file. To do that, we need to select the node we're interested in this case points. Then we go to the menu item Analyze and select Evaluate Results. This generates the net intensity for each of the identified elements in each of the spectra which are contained in that node. With this node still selected, I now want to select Export and select Results to Excel. And I click that item. I will be asked to save the data, and I want to make sure I go back and select my temporary file, and I will call this Art Test. That should have saved the data in an Excel format, as I said, with the net intensities for each element in each of the spectra. If I now go to the File Explorer and go to Drive C and go to Temp, I find my art test Excel file. And in this case, when I open it, what I have is I have two sheets. The first sheet contains all of the parameters from the data acquisition. The second sheet contains the net intensities for each of the elements in each of the spectra. I can then take this data and manipulate it in many different ways. For example, if I take the intensity column or the name column and select it, and the lead intensity column and select that, I can then insert a bar graph which shows me the net intensity of the lead in each of the various colors. This clearly shows that the tan color on my painting has the most lead, the blue color has substantial lead, but the other four colors have relatively little lead. You can do any Excel manipulation you like with Excel and the data. For example, one semi-quantitative measure used in many cases is the ratio of the various intensities in these spectra. Finally, to save a project for future use, you go to File, Save Project As, and again you want to select the appropriate location and give the project a name. Again, we'll call this Art Test. Then in the future you can reopen that project and do additional manipulation. This brings us to the end of this video. Thank you for your attention.